Hello all. I am going to go through the quiz from Monday because a lot of you guys had some trouble with it. If you understand where you made your mistakes and you try to study through the quiz that you took, I think that you'll do just fine on the makeup. So let's take a look at number 1. So we have 3x squared times 2x cubed. So the first thing I'm going to do is take my coefficients. 3 times 2 is 6, so that is my coefficient, and that goes first. Next, I have x squared and x cubed. They're not like terms, however, because we're multiplying, we can follow our exponent rules, and because that is multiplying, we do 2 plus 3, which is 5. So my final answer is 6x to the 5th. Next, we have number 2. X to the 0 is just 1. That means we have 3 times 1 times 2x, right? So that just means 3 times 2x, which is just 6x. For number 3, I'm going to go ahead and do the top here first. Since they have the same base, we know that multiplication rule says a to the x times a to the y equals a to the x plus y. Therefore, this will be 3 to the 3 plus 3, which is 6. And that's over 3 to the third to the negative first power. So I'm going to distribute the exponent, and I'll have 3 to the negative third. We also know that a to the x over a to the y is equal to a to the x minus y. Therefore, this is 3 to the 6 minus negative 3, which is 3 to the 9th, which is 19,683. For number 4, we'll go ahead and start with the top and distributing that exponent. So we have 3 to the 6th over 9. Well, I could just write 9 as 3 to the 2nd. So that would mean I would have 3 to the 6th over 3 to the 2nd, which would just be 3 to the 4th, which is 81. The other way you could have done that would have just said, okay, well, I've got 3 to the 6th over 9. 3 to the 6th is 729 over 9. Well, that simplifies to be 81. And so that is the first 4 problems. Now we can go on to number 5 and number 6. Alrighty. So I have 3. I'm going to go ahead and write this out as a fraction now, because now it's starting to look a little bit complicated, right? So I'm going to go ahead and do 3 over 1 times a squared times a cubed over 1 times 2 to the 2nd over 1 times a to the 4th over 1. Alright, since everything's over 1 currently, and we don't have any negative exponents, I don't need to have them as fractions. So I'll have 3 times 2 squared, because I want to move that to the front, times a squared times a cubed times a to the 4th. So 2 squared is just 4, so 3 times 4 is 12. And then a squared times a cubed times a to the 4th would be a to the 2 plus 3 plus 4, which is a to the 9th. And here for number 6, I have 2 times b to the negative third times 2 cubed times b to the 6th. So this is just 8. This is 1 over b to the 3rd. So that means I have 2 times 8 times 1 over b to the 3rd times b to the 6th, so I can just put the b to the 6th right here on top, which means I have 16b to the 3rd. So here is the first page. So for number 7, I've got negative 2 times x cubed times 1 over y times x to the 0 to the negative 5th, that is going to be still x to the 0, which is 1. So I don't need to write anything there. Then y to the negative 20th, or 1 over y to the 20th. So put that over 1 and that over 1. That means that I have negative 2x cubed over y to the 21st. So here, I've got 2 to the negative 1st times x to the negative 3rd times y to the 1st, because negative 1 times negative 1 is 1, times x squared times y to the 4th. So here's a situation where I can go ahead and go 1 over 2 times, I'll put the x squared on top and the x to the 3rd on the bottom, because this is just the same as 1 over x to the 3rd, right? And times y to the 5th, because it's y to the 1 plus 4 over 1. This one will just be 1 over x, because it would have been x to the negative 1 had you subtracted. And that's the same as 1 over x to the 1st. So my final answer will be y to the 5th over 2x. Alrighty, so for this one, you're welcome. And we've got 2 times x squared times 1 over y to the 4th times 2 times 1 over x to the 5th times 1 over y. Okay, so I can put those together, and I can put these together, and I can put these together. So I've got 4 times x squared over x to the 5th times 1 over y to the 5th, which is 4 times x to the negative 3rd times 1 over y to the 5th. This is 1 over x to the 3rd. So I've got 4 over x to the 3rd y to the 5th. Here I need to distribute my 4. So I've got x to the 8th, y to the 20th, negative 2 to the 4th, x to the negative 4th, y to the 20th. So this is going to be negative 2 times negative 2 times negative 2 times negative 2, which is 16. That's my coefficient. Then I have x to the 8th and x to the negative 4th. I have to add those together, so I've got x to the 4th, y to the 20th, and y to the 20th, so I have y to the 40th. So I've got 16, x to the 4th, y to the 40th as my final answer. So here, both of all of our coefficients in the inside are negative. So basically this is saying negative 1 times y to the negative 1 over negative 1 times y to the negative 2 times negative 2 times x squared times y to the 4th, all to the negative 4th power. So that is going to be, let me actually go over here to have a little more room. So this will be negative 1 to the negative 4th times y to the 4th over negative 1 to the negative 4th times y to the 8th times negative 2 to the negative 4th times x to the negative 8th times y to the negative 16th. Okay, so the top here, negative 1 to the negative 4th is still just going to be 1, because you have negative 1 times negative 1 times negative 1 times negative 1 to the negative 4th power. So it's 1 to the negative 4th power, which is 1 over 1 to the 4th. And it becomes 1 still. So the top just stays y to the 4th. So since this one is just 1, this one is also just 1. So now let me spread this one out a little bit more just so that it's a little clearer. I'm going to go ahead and write these as fractions. So the top is y to the 4th over 1 times 1 over y to the 8th times 1 over negative 2 to the negative 4th times 1 over x to the negative 8th times y, 1 over y to the negative 16th. Okay? So this one is just going to stay the same, as will 1 over y to the 8th. So I'm going to now start combining my like bases. So I have y to the 4th, and then over y to the 8th, and I'm going to leave a little room because I know that I also have this y to the negative 11th. I'm sorry, negative 16th. I can't read my own writing. The next piece is here. So remember that 1 over a to the negative x is a to the x, because the negative portion of a negative exponent, it doesn't tell us anything about the coefficient. It just tells us that we're talking about the reciprocal, which means that this is actually negative 2 to the 4th over 1, because it's reciprocal. Then I also have 1 over x to the negative 8th. So again, that means it's the reciprocal. And then finally, I have this last y, which just means it's y to the 16th over 1. But instead of writing it here, I'm going to go ahead and just multiply it here. So the final step for this problem is this. We're going to go ahead and combine these and these. So we have y to the 20th over y to the 8th, which means we have y to the 12th. This one is going to be a negative 2 times itself 4 times, which will be 16. And this one will just stay the same. So my final answer will be 16, x to the 8th, y to the 12th, because I need to put it in the correct order, so I've got number and then alphabetical order and variables. This one's actually quite a bit easier in my opinion. This we can just get rid of because it's just 1. I'm going to combine my negative 2 and my 2 here, so I have negative 4. I can combine my m's, so I have m to the 8th and to the 4th on top, over 2 squared, which is 4, m to the negative 4, n to the negative 4. So that is just negative 4 over 4 times m to the 8th over m to the negative 4th times n to the 4th over n to the negative 4th, which this is just negative 1. This is m to the 8th minus 4, so it's m to the 12th, and n to the 4th minus negative 4, which is n to the 8th. So my final answer is negative m to the 12th, n to the 8th. So there's all that. So I skipped over number 12 and number 13, which I will go through now. Alrighty, so for number 12, I'm going to go ahead and distribute the exponents. So I'll have 2 to the 3rd, m to the negative 6th times 1, which I'll leave out, times 2 to the 3rd, times m to the negative 9th, times n to the negative 12th, that's all on top, over negative 1 to the 3rd, which is still negative 1, m to the negative 6th, n to the negative 6th. So now my next step, I'm going to go ahead and separate these into common bases and constants. So 2 to the 3rd is 8. So I've got 8 times 8 with my coefficients divided by negative 1. So it's going to be negative 8 times 8, which is just going to be negative 64. And then I have m to the negative 6th and m to the negative 9th, which is m to the negative 15th, over m to the negative 6th times n to the negative 12th over n to the negative 6th. So now I have negative 64, m to the negative 15 minus negative 6 is going to be negative 9, n to the negative 12th minus negative 6 is n to the negative 6th. That's still not simplified because you can't have negative exponents, which means that we will have negative 64 times 1 over m to the 9th and times 1 over n to the 6th, which is how I got that answer. And for number 13, we have y to the negative 6th on top then we have these combined to just still stay x to the third. And these combine to be y to the first, because it's 3 plus negative 2. And we just have that 2 in the front, so that stays there, because it's a coefficient. So that means I have y to the negative 6th over 1 times 1 over 2x cubed y to the first. That's another way to write what I just had. And this goes with that, so my next step will be 1 over 2x to the third times y to the negative 6 over y. Negative 6 minus minus 1 is going to be negative 7, which is 1 over y to the 7th. So what that tells me is my final answer will be 1 over 2x cubed times 1 over y to the 7th, which is 1 over 2x cubed y to the 7th. So I was hoping that this was going to be the gimme page, and I'm sure that once you see this explained, you'll probably remember it if you missed anything on this page. Just looking at these ones here on top, I know I need to name the polynomial and name the degree. So just quickly browsing through, I know this is a monomial because there's only the one piece. This is a binomial because there's the two terms. This is also a binomial, and this is a trinomial. Now, to name the degree, recall that the degree of a polynomial is the exponent of the biggest exponent or sum of exponents in the polynomial. So, for example, here, it's a 5th degree binomial. Here, for number 18, though, I need to figure out each term's degree. So this term's degree will be 4 plus 3, which is 7. This is 2. And this is 8. So the biggest biggest degree we're dealing with is 8. So it's an 8th degree trinomial. Here, 3 plus 5 and 4 because it's 2 plus 2, which means it's an 8th degree binomial. And this one is technically times x to the 0 power because it's times 1, which means it's a 0th degree monomial. If it was negative 10x, it would be a 1st degree. For the next ones, you can either, you're simplifying each expression, and you have to combine like terms. Remember that like terms need to have the same variable and the same exponent. Both the same variable and the same exponent. So you can combine these vertically or horizontally. I'll show you both. So the first one I'll go ahead and solve horizontally. I can drop the parentheses on the first quantity. I can also drop the parentheses on the second quantity because it's an addition problem, and so I don't have to distribute anything. So 7 to the 4th and n to the 4th are like terms. Remember, there's an imaginary 1 there. Therefore, I have 8 n to the 4th. And then negative 4n cubed and positive 5n cubed are like terms. Those combine to be positive 1n cubed, which is just n cubed. For the next one, I'll go ahead and notice this negative. That means I have 6x minus 7x cubed plus negative 4x minus 2x to the 4th, which means that I can just do the additive inverse here. So I have 6x minus 7x cubed plus negative 4x, and then a negative distributed is going to be positive 2x to the 4th, which means that 2x to the 4th will start my polynomial answer because I'll put it in the correct order even though that was not required for the quiz. There's no other x to the 4th, so there's no other like terms. Same with negative 7x cubed. That's the only x cubed. And then there's the 6x and the negative 4x. Those combine to be a positive 2x. That is as simple as it gets. And so that is going to be your final answer. All right, for the next one, I'm going to set it up vertically. The reason I'm going to do that is because there's two variables, so I'm going to think of this sort of like a system of equations. So I've got 5u cubed plus u cubed v cubed plus 8u cubed, so I can put that here because those are like terms, minus 6u cubed v cubed, so that means that these are also like terms, plus 6u squared v squared. That doesn't have any like terms, so that's just going to go over here. I can just bring that down because I know that I'm not adding anything to it. These will be 13u cubed, and this will be negative 5u cubed v cubed. That's my final answer. I'll do the same thing over here. There was, it looks like it got a little bit cut off, so this is actually m to the 4th, n to the 2nd. So I'm going to go ahead and set this up vertically. 7m to the 4th n squared plus 5m squared n to the 4th. Now, since we have a subtraction sign, I'm going to do the additive inverse of this, meaning I'm going to change the sign of every piece of it so that I can be adding the inverse. So I have negative 3n. There's no n's up there, so I'm just going to put that over here on the side because it doesn't have any like terms. It's going to be positive 4m squared n to the 4th, which will go underneath the other m squared n to the 4th. And then it's a negative 2m to the 4th n squared. Again, that's because it's the inverse. So I can combine these, and I'll have 5m to the 4th n to the 2nd plus 9m to the 4th n to the 8th minus 3n. And that is the final answer. So for the next page, I'm just going to go ahead and explain what I did here. I went ahead and just wrote this first expression here, and I just wrote it normal. Since it's a plus sign, I don't have to do any keep, change, and I'll line up the same like terms underneath. Since there's no constants in the first expression, I'm going to put the constant here on the end, and this is the answer. Similarly, here, I am going to line up my like terms, but for this one I had a minus, so I turned this into the additive inverse, which meant that I had to turn this guy negative and this guy positive. There was no other y cubed, so y cubed's on the end, and you should have had that. So 8a to the 4th b plus 2 minus 5b squared. I'm going to add the inverse. There is no like term here, so I'm going to put the inverse here. And this goes here, and it's a positive 5 because it's the inverse, and a positive b squared, so that your final answer will be 8a to the 4th b plus 7 minus 4b squared minus 8a to the 4th b to the 3rd. And finally, this last problem is simply addition, so you should get this right here. I believe I will skip this for the retake. If you feel like practicing it on your own, I'll just tell you the answers, and then I'll throw it on a test another time, and we'll talk about it prior, hopefully. This one should have been 2 gallons. This should have been 7 meters cubed. This one should have been 6 feet cubed, and this should have been 31%. So that's if you tried it. If you didn't, don't worry about it. I'm not going to put it on the retake. So I hope this helped you guys, and study. Practice these questions and questions similar, and I will see you all next week.